Hey fellow hobbyists, today I'm going to be modeling a custom fan shroud for one of my lighting controller boxes, and I thought it might be a good chance to show some of you some basic modeling techniques in case you ever wanted to get involved and start modeling and creating your own custom solutions. Now the fan I'm creating a vent for is very simple, standard 40-40 fan, 40 millimeter by 40 millimeter external perimeter. What's nice about something standard like that is their existing drawings. You don't have to go measure all the dimensions that are critical to your design. You can look it up and just model based on that. So that's what we're going to do rather than having to model something or measure something custom. So the first thing we need to do is go ahead and create our first sketch. I like to model things in the orientation, in their installation orientation. Some people don't, but that's what I'm going to do. So my box will be upright. So I'm going to mount it on this, or I'm going to model it on this front face. One of the first things I always do when modeling is I create center lines. Sometimes I use them, sometimes I don't, but just as a general practice, they make doing constraints much easier. And so I'm picking a line up here. Oops. Picking a line and then picking center line to make that a dashed line. It's a little hard to see on the red, but you can see how it's a dashed line, meaning that's not an actual model construct, but just something that I can use to set constraints off of. Unfortunately, in Fusion, you're not guaranteed that even though these look like they're perpendicular and around this origin point, you're not guaranteed that. So I'm going to go ahead and pick a coincident constraint, click my line, and then click this origin. Now it's guaranteed to be on that origin. I'm going to do the same thing here, and now they're both exactly on that origin. I can see right here that it did apply a perpendicular constraint to these two lines, so they are at 90 degrees, and this is telling me that this is going to be vertical. Now, just to double check, I always like to go ahead and say, hey, horizontal, vertical, and I'm going to click this line. It says, hey, that's over constrained because of this perpendicularity constraint combined with this horizontal constraint. So that's okay. That just means that I am guaranteed that these are what I want. They are a perpendicular set of construction axes around the origin. So what that lets me start to do is I can now go ahead and start my feature set knowing that I have a good reference point if I ever want to do any symmetry constraints, which especially for design like this fan, I will want to do. So I'm going to pick a 2-point rectangle, but I'm going to come over here to my sketch palette and do a center rectangle because this is going to be a symmetric square that I'm creating. So I'm going to go ahead and just create it in roughly the dimensions I need. A mistake a lot of beginners make is they try to create their initial features at exactly the size that they want them to be versus roughly the size they want them to be. So just create a square or a rectangle and of approximate dimensions you want, and then come in and size it using your actual entry box here. Another thing I know from the drawing that I had pulled up earlier is that this is a square, not a rectangle. So I use this equal constraint, click this line, then this line, and that makes these lines, makes this an actual square. And you can tell that because all these lines turned black. So if I undo what I just did with Control Z, you'll notice this line's blue and this line's black. So the fact I did a center rectangle, it automatically makes these symmetric around this center point. But this dimension is telling me, the fact this is blue is telling me it's what we call partially constrained, meaning I can still move this. Whereas this black line, I can't move it. I can click on it and drag and nothing happens because he's constrained by this. What you really want is you want fully constrained models. And so I'm going to use this equal sign to set this side equal to this side. Now when I do that, it automatically resizes to a square, and you'll notice all my lines are black now, not blue. So that means this model is fully constrained. I cannot move any of these items. They're fully dimensioned. It's completely parameterized. This square is now where I want it to be. Now the other nice thing about doing this as a center point rectangle, so over here this center rectangle, is if you look back over to our drawing that gives us our dimensions here, these square or these circles for my bolts are all going to need to be symmetric. They're all equally spaced around the fan housing. So this center point rectangle gives me these diagonals. And if I put my circles on those diagonals, it just makes it a lot easier to then make everything symmetric because I can make sure this green is on this diagonal. You can see I'll get a green line there whenever I am horizontal to this circle, which is what I want. So we're going to go ahead and create the rest of these circles, and then we'll dimension them as well. So again, this is not the actual size of the circles. I just made 4 randomly sized circles of about the size I wanted. I'm going to come back through here with this sketch dimension, click on the circle, click out here, and I know those are 4 millimeters per the drawing. However, I'm going to 3D print this, and my 3D printer has some tolerance in it that I've just learned over time of using it, so I'm actually going to size these at 4.3 millimeters. That will allow my through-hole bolt to pass through cleanly without the threads catching on the hole. Now you'll notice all these are still blue, and we talked earlier about wanting to have things fully dimensioned. So one thing, I'm going to use this equal constraint to apply this 4.3 to all 4 of the other circles. Now I could do that by just dimensioning all of these circles as well, 4.3, and put it all the way through all these circles, 4.3. But let's say I go through and I 3D print this and realize that, oops, it should have been 4.4 for good clearance. Well, now I have to go change 4 dimensions. Instead, if I use this equal here and just say, hey, this circle's size is equal to this circle's size, and this circle's size is equal to this one, and this one is equal to this one. Now I can just change 1 dimension, and all my circles change. So use constraints wherever you can, and it greatly simplifies your ability to scale and modify your drawing. Another thing, even though those green lines that showed up that showed that I placed these as horizontal and vertical items, we really want to make sure that happens. So I'm going to go through and manually apply that constraint as well to all of these. And that, in a lot of cases, is going to say it's over constrained because it already did it, but that's okay. I really want to make sure that happened. So actually it's showing me it did not automatically apply those. And oh, that one did. So sketch geometry is over constrained. Again, that's okay. It just means that that constraint was already there. So we have one more thing we really want to make sure we do, because you notice these are still blue. So if we're curious about what is unconstrained, we can grab these and just see how they can move. And you notice they are all symmetric, right? They all move together. But there's obviously a missing dimension. It's the hole spacing. So how far apart are the holes? So I'm going to go look on another screen here over to my hole dimensions, and those are 32 millimeters. So we're going to go to type in 32 here. Now you'll notice all my lines everywhere are black. This drawing, these holes, everything is fully constrained. I like to put as much as I can into the sketch, and then when I do cuts and extrusions, I can just keep referring to the same sketch. That's a little unique, at least for me, because most of the other modeling packages I use, I've used professionally, you have to extrude the entirety of a sketch. Fusion 360 will allow you to pick features within a sketch to extrude or cut, so it makes it kind of nice because you can go ahead and do everything against common sets of constraints. So this fan shroud that I'm going to make, I actually am going to press nuts into it. So that the bolts on the other side that I'm going to push in from the other side can thread into the nuts on this. Now that is obviously a horrible hex nut hole, but that's okay because again, constraints, right? I'm not going to try and make this exact. I'll make it approximate, and we will. Oops, I didn't want that coincident. Maybe I do. Maybe I don't. I don't know. We'll see what the dimensions are. So this obviously is not the right shape. Let's go ahead and start using constraints again. One thing we know, all the sides will be equal because all the sides of the nut that will be placed there are going to be equal. So we'll just go ahead and start applying some constraints. That looks a little better. Kind of drag it into the right general shape. And now I can start applying things like horizontals and verticals. So we know that these are going to be directly above each other. And we know that these are going to be these 2 vertices are going to be directly horizontal to each other. So hit escape. Escape's always a good key to kind of get out of whatever we were stuck in. And now I want to drag this guy around this hole. So I need to be symmetric about this hole. So I'm going to add another center line around this hole just to make things easy on myself. So let's make that center line vertical, and let's make it coincident with the center of my circle. And now I can use this symmetry constraint right here to hit these 2 vertices and put it around this hole right here. And then I can use my horizontal constraint with the center of the circle and one of these vertices, and now I have the sketch of the outline of the cavity where it needs to be. So I can go through here and dimension it in accordance with that drawing that we were just looking at that says that this needs to be 7.1. Second set of dimensions between these flats. And if I make that match the first, now we'll notice I have all my lines are black. So this is a fully constrained sketch. Now I'm not going to duplicate that sketch because when I do this cut, I'm going to replicate that using a pattern feature that we'll show later. There's no reason for me to go create this over and over and over again. I probably could have done the same with the holes, but I'm going to approach those a little differently, and I'll show you that later. I think this is all the features I want to put on my base drawing. I don't think I need a perimeter this big now that I kind of see what this looks like, so I'm going to bring this down to about 55. No reason to waste the extra material. So now I have this feature set, and I want to go ahead and create my extrusion. So I'm going to hit the extrude button. And the pieces I want to extrude to start are going to be everything except the holes. And I'll show you why that is in a second, because we're going to re-extrude some of this as a cut, but a partial cut. So I'm going to select all of these items, and you can do a lot of things in this panel, and that's where I'll end, but I'm going to rotate this with middle mouse and my middle mouse wheel button by clicking and moving that around. And now I can see this arrow and get some perspective about what I'm doing with this extrusion. So 5 millimeters, that's probably good for what I want. That's, just under a quarter inch, and that's probably good. So we're going to go -5. We're going to lock that in, and it's going to extrude a very boring looking rectangle. Sometimes after you've done an extrusion, your Fusion 360 might hide this sketch automatically because it says, hey, you already extruded from that sketch, you must be done with it. In our case, we are not done with that sketch. So if that happens to you, you just need to go over here to your model browser, hit this drop down, and then unhide. Click that little eye to show your sketch. And now you'll see I can see my sketch again. The next thing I want to do is go ahead and extrude my bolt holes, or the holes that are going to press fit the nut into. And I want those to be cuts, not extrusions. So I don't want that. I actually want it to go the other way, but I don't want it to go all the way through. So I'm going to click and drag that, and Fusion's smart enough to realize that since I went into the material, it changes this operation to cut. I'm going to go about -2.5. Oops. I obviously did not extrude that enough. So in this situation where I made a mistake and did not extrude it far enough, it did extrude the cut, but that's not deep enough to press fit the nut into. You can come down here. This is your model history, and you can just double click on any feature that you want to change. So I'm going to double click on this extrusion because I obviously did it wrong. Instead of 2.5, I put 0.25. So 2.5, and that needs to be a negative because it's a cut, or because it's going into the material. Now I have a nice deep recess to put the piece in. Now that's just one of them. I plan on putting 4 in here for the 4 bolts to thread into. So the easiest way to do that is with this rectangular pattern tool. Now we can do that off feature sets, but we are going to go ahead and do features. We're going to select features, and now it's saying, hey, what feature do you want to repeat? And what we want is my last extrusion, which was that cut. So I'm going to come down here to the model tree and click that extrusion. Then it says, hey, what are the axes you want? Well, I want to pick 2 axes. I'm going to want to do it, I'm going to extrude in this direction and in this direction. So now I've picked 2 axes, and it adds those to my rectangular pattern tool over here. So for quantity, we're just doing 2 of each. So I'm going to hit this down arrow to change these to 2 and 2. Now right now they're right on top of each other, so just to get a visual approximation, we can go ahead and drag these guys across. Now from our prior drawings, we know exactly what that dimension should be, and that dimension happens to be exactly 32 millimeters. Fusion's also pretty smart, and it says, oh, you probably want to use this circle, so it automatically finished putting it right there when I was doing that drag. If it didn't get that right, you can go into this distance box and type the actual distance that you want it to be. In our case, it's 32 millimeters from our drawing earlier. So I'm just going to do that and hit OK. Now you'll notice I have 4 recesses to put my pieces in so that I can thread through my lighting controller box through this hole and into the nut that's here so that it will hold the fan shroud in place. Now earlier I called this the room for the gasket. This is actually what I'm going to sweep for the fan hood. That I'm going to sweep it a bit over like this to protect from any water or other ingress of other things I don't want. A similar pattern is going to be repeated on the back that will be a cut. But this is going to be a sweep to form the actual fan shroud part that protects it from the elements. Now there's one more piece that I noticed I forgot, and that is, well, the circle for the fan. How does the air get through this? So I'm going to go revisit my original sketch, again from this model history down in the bottom left of the screen. I'm going to double click on that sketch so I can get in to edit it again. And we have one more feature to add here, center diameter circle. We're going to click that. Also, shortcut key is C. So I can hit C, and now I can create this circle. Really only one dimension needed because we clicked on the center of this whole sketch. Symmetry really saves us a lot of trouble here. And now all we have to do is add a dimension. Per the drawing we had up earlier, that dimension should be, let's go over here and see. Looks like that dimension is 38.7 millimeters. So let's go ahead and make that 38.7. There we go. Now I can finish with this sketch again, and I can go ahead and extrude that. Oops, selected too many things. Unselect them all with that X. Select that piece, that piece, that piece, and that piece. And I want this to be a cut. So I over drag. Again, a lot of people when they're new to modeling, they try and be very careful and get this right at the edge of the part. And you can do that, but I'm just going to drag it out. And I'm going to go here and say through all. And now it says, oh, okay, you want to go through anything that's there. And that's what I'm going to say is okay to. I do have one interesting thing that I want to point out is you notice it did not cut this piece right here. So let's go back into this extrusion and we can see why. I picked these 4 quadrants of the circle, but it did not get this little piece. So I'm going to grab that little piece too and then hit OK. Now it got rid of that and I have the full area for my fan to flow through. Again, you can go through and fix this. You can move these bolts, you can shrink this circle, you can make these smaller, there's lots of ways to fix it. It doesn't have to be an M4 bolt, it could be an M3, but in my case, this is fine. Okay, so now we have the kind of mounting plate done, so we want to go ahead and extrude the fan shroud. Now, we're not just going to do a standard extrude here, or else we end up with something like this. So if I grab all these pieces and I hit extrude, we end up with something like this. Well, I guess you could argue that would work. It would prevent mostly from a lot of your elements, but it's not very aesthetically pleasing. It's a waste of a lot of material. This isn't a great design, but it could work. So I want to show you another technique that a lot of people don't use it because they find it scary because they're unfamiliar with it, but it's really pretty straightforward. And that if you hit this drop down in the create menu, we can do what's called a sweep. And you have these really funny shapes that this shows that you can create. And that's really powerful, but it can be a little bit tricky. So we're going to go ahead and do a sweep But what we have to do, or I want to pull up the sweep menu just to show you what that looks like. So we have this thing, profile. Well, profile is, hey, what is the thing that I'm going to sweep along the path that I subsequently sketch? And then we have path. So you can think of a sweep as an extrusion, or you can think of an extrusion as a sweep whose path is a straight line. So in an extrusion, we're just extruding straight up or straight down. That's still a sweep. It's just a sweep with a straight line. A sweep allows us to make that line take different forms and shapes and paths. So in this case, let me rotate this to the right side here. I want this profile to kind of go up and curve over to the right like this, right? Create kind of a curved hood for this thing. So I need to draw that path. Right now that path doesn't exist. So we're going to go ahead and cancel, but hopefully that helps it make sense what I'm about to do. With a sweep, we have to tell it what that path is, and that path is going to take the form of a sketch. So I want to extrude this kind of these outside rectangles here that are going to form the vent hood. But I have to tell the sweep where they're going to extrude to. So I have to create another sketch to tell it how to extrude these. I need a dimension to do that before we do so though. So I'm going to measure this distance, which it tells me is 2.5 millimeters. And then I need to know this distance between 1 and 2. And that distance is actually going to reset, and we're going to pick these two guys. And that distance is also 2.5. So that means the middle of this is 1.25. So the middle of this line is going to be 1.25 plus 2.5. So 3.75 is the midpoint of these two lines. And that's important when I create my path, and I'll show you why. So let's go ahead and create another sketch for our path. Now, because we used all this symmetry and we built about the origin, we don't have to build a construction plane. We get to just pick the existing origin plane that we started with. Now, the path we're going to extrude that shape is going to be something like, I just want to make sure I'm drawing on the right side here. I'm a little turned around because it's upside down. It's going to come out a little bit like this, then it's going to go down at an angle like this. So this is kind of the path we want to extrude these rectangles along. We're going to bring them out a little and then sweep them down a little. Now, where this point is, where it lies between these two lines is very important. That's why I took the measurements I took earlier. It needs to be in the middle where you're going to get some really weird artifacts when you try to sweep this. I really want this to be in the middle of these two lines, so I'm going to dimension it at the 3.75 millimeters that we derived from our measurements earlier. And that puts it right in the middle of those two lines. Now, as always, we want fully dimensioned sketches, so this is not fully dimensioned. This line is, but this line is not, because I can do all kinds of things with this line, right? We need to fully dimension him so that we have a well-specified drawing. So the first thing I'm going to do is dimension the angle, right? How steep do we want this water runoff to be? And 115 is just kind of what I like to go with. It's going to give me access to get in here. That's one of the reasons I have this straight line here is, remember, there are two places I have to press parts into, like right in here. And my fingers are not small enough to do that if this straight piece here didn't exist. I wouldn't be able to fit those pieces in. Maybe with some tweezers or something, but it would be really hard. I'm going to give my room to get my stubby little fingers in here and press those in. 115s is a pretty good water runoff angle. This is somewhat arbitrary. You can make it bigger or smaller, but I'm going to go with 115. Other dimension I need is I need to tell it how big is this piece. Well, I want it to be about 8 millimeters off. It gives me about a 1/4 inch to fit. And then how long is this line? We'll go ahead and go 36. That looks good to me. Now you'll notice there's still room for it to move. Let's see why, right? If we grab this point and see what can it do? Oh, look, it can move. Right? Because I never told it that this point had to be on this line. So let's go ahead and say coincident. This point is coincident with this surface. Now we're fully constrained. I can't move any of this stuff around. I can't change the angles. I can't do anything. Everything's fully constrained, and that's going to lead to a predictable behavior of our sweep. So I'm going to head and hit finish sketch. So now maybe you can kind of visualize it, but this outer U shape of rectangles here, I'm going to sweep along this path. Now we have all the things we need to do our sweep, and let me show you what a neat little tool this is. So we hit this create drop down. It's not one of the defaults that's typically up here since it's used less often than things like revolves, patterns, and extrudes. We'll go down here, we pick sweep, and we're going to select all these little rectangle pieces that form our shroud. For the profile, so 4 selected because I picked 4 little segments here. And then we're going to click on the arrow for path. We can leave everything else as defaults for the way we've done this. And I'm just going to click this line that we just sketched. And boom, there we go. Look how easy it was to get a well-contoured shroud. We didn't have to make a bunch of little rectangles and cuts, because that's the thing. You can do this without a sweep. You could create a bunch of constructed and angular planes. You could create a bunch of cuts and separate extrudes. I could have extruded each of these sides and this top. Like, there's a bunch of different ways you can create the same geometry, but there's not many that's much easier than the sweep that we just created. So I'm going to hit OK. I'm going to go ahead and hide these sketches so we can look at what it looks like. And that's pretty close to what I wanted as a base shape. Now we are pretty close to where we want to be with this guy. I'm going to add some rounds just aesthetically. It doesn't really need it. I could call this model done and good enough, but I'm going to go ahead and add some rounds and chamfers just because I think it looks a little bit better. So one of the ways we can do that is we come up here and you see this modify. So I mentioned while I was drawing this that I wasn't going to round a bunch of edges and things like that inside the sketches. It's a lot of work to do that inside the sketches and get all your circles centered properly. And it makes, if you're going to do formal drawings of these things, it makes them kind of hard. Whereas I can just round it after, and it makes things much more scalable if I ever change my design. So I'm going to come in here and I'm going to do, Fusion 360 calls it a fillet. Every other thing I've ever used calls it a round. It's the same thing. So it creates a rounded edge. So it's going to bring up this fillet window, and I'm going to leave it as rolling ball. And we're going to start by rounding these outer edges. So just clicking them one at a time. I'm not holding control or anything. This dialog just assumes that everything you click you wish to add to the selection set. So you'll notice it's got those 4 that it selected. And I'm going to go ahead and say, I don't know, maybe let's go with a 2mm round. And the nice part is it shows you that in real time. You can kind of see what that round would actually look like. And 2 looks pretty good. I think I'm going to stick with 2. These are the primary rounds I wanted to add to the model. But I'm going to go ahead and add some to round the exterior of this shroud as well. I'm not going to round the interior. Aesthetically, I would like to round the interior, but for the sake of 3D printing, keeping this as a full vertical face, and this is a full vertical face, is actually going to make things a lot more reliable to print. So I'm going to leave the inside of this kind of Spartan and rectangular, but I'm going to round the outside of this. It's another reason it's nice to do these rounds after the fact is you can kind of pick and choose which edges you actually apply it to as opposed to the entire contour. 2 might be a little much, but we'll try it. We'll see what it looks like. Hey, that looks pretty good. I'm actually going to try out some 3, and I like the way that looks. So there we go. And that should be good enough to go ahead and export and print. Now, before I export this, I want to set the quality of what that export's going to be, especially since I created rounds, STL and step files with rounds. When you export these as STL or step files, it's creating a bunch of triangles and edges and things like that. And for the best export and the best print, you want those triangles to be really small so that you can as closely approximate these rounded features as possible. And so I'm going to go in and change what some of those settings are. So to improve those settings, what I can do is I go to this File menu and then 3D Print. And I'm going to say that I will want an STL binary, unit type's fine, and I'm going to select my part. So So now that we've selected our part, we can go ahead and hit preview just to get an idea of what that STL will actually look like. And we can see where it's creating the shapes to try and approximate things like rounds. You can only create linear shapes, so you don't get a true circle. You can see the approximation it's doing against the gray line that was the circle, and how all of these are actually straight lines. So you don't get a real circle when you do an export, you just get a bunch of really small straight lines. And the smaller those lines are, the more accurate you are towards being a true round. And some models it matters, some models it doesn't. This model, it's not all that important. It'll be round enough for what I need. And the round will probably be better than the step size, the vertical step size for when I print it. But I'm going to go ahead and refine it just a little bit. And we can watch this triangle count. This triangle can go up or down as we change these settings. This triangle count is really what it is, kind of a way of thinking about the level of detail in your model. More triangles, more detail. You may or may not need that detail. So more triangles is not necessarily better, because more triangles does equal a bigger file as well, and you might not need that. Like, I don't really need much more than what's here, but we'll go and play with a few settings just to see what else we can come up with. And you can see how I'm increasing triangle count as I change, in this case, the normal deviation parameter. I'm now up to 4,000. I originally started at about 3,000. I can change maximum edge lengths. This is one of the big ones that typically changes triangle count quite a bit. 5240 now. But you can play with these settings to get the level of detail you want in your model. And I'm just going to hit OK. And so it says, hey, well, where do you want to export this to? So you'll set the directory. It's going to be an STL file, and then you name what that export will be.